So we will discuss chain rule of partial differentiation in multivariable calculus. So before that, we need to know what is called as total differential. So in partial differentiation, well, there is just simple one difference I should note. So differentiation, in partial differentiation of a function of two or more variables, two or more variables, what we generally do is that, well, I should say only one. So only one variable varies. So while we calculating the partial differentiation, what we do, we just variate only the one variable. But in total differentiation, all variables, or I should say, instead of using this word, I should go for this increments, that is the change, are done simultaneously in all variables. So how to represent this? So to represent this, we generally write total differential coefficient of one function. Well, to understand that, let z is equal to f of xy be a function. So if we change x by some delta x and y by some delta y, we change by a small increment or small change in x and small change in y, then there will be a small change a small change in z also, in z. Say, I will say this as delta z. So corresponding to the changes delta x and delta y, I will have changes in z, say delta z. So how this will look? So z plus delta z is actually f of x plus delta x comma y plus delta y. So delta y. So let's call this as equation 1 and equation 2. So if we subtract equation 1 from equation 2, we get delta z as f of x plus delta x, y plus delta y minus f of xy. Well, I will simply add and subtract one quantity. I will simply add and subtract this quantity, f of x comma y plus delta y, and I will subtract it. So f of x comma y plus delta y plus, so that's the minus f of x comma y. Notice these two terms. Notice that We'll club these two and these two. So how this will look? My delta z will look like f of x plus delta x comma y plus delta y minus f of x comma y plus delta y. I will divide it by delta x and multiply also by delta x. And the next quantity is f of x comma y plus delta y minus f of xy whole divided by, I will again do the same thing with delta. Now, as delta x tends to 0 and delta y tends to 0, notice that this quantity, this is delta z as it is, or instead of delta z, since we are taking the limit, I will simply write this as dz because we are tending it to the 0. So note that first quantity is actually del f by del x into this quantity will become dx. This quantity will become dx. Similarly, this quantity is del f by del y, and this delta y will become differential in y or small change in y. So here this dz is called the total differential coefficient. The total differential coefficient. Now we want to change the variables. So we know that x comma y are independent variables. So they are independent variables. Independent variables. Suppose my x is a function of x of t, some t, and y is also a function of y of t. Then, and my z is again a function of x and y. Then by above formula, so call this formula as 4. So from a 4, I can write, well, I will write the 4 once one more time. So dz is del f by del x dx plus del f by del y dy. This is a number 4 formula. If I divide it by t or divide it by dt, what I will get? I will get dz by dt equal to del f by del x into del x dx by dt plus del f by del y into dy by dt. So this is the formula, say equation number 5, to change variable from xy to t. Now, if what if